Homework for 8.6, solving equations. And let's see how these go. Okay, it says solve each equation for x, I suppose, since there's a variable there. Square root of x minus 2 is equal to 3. The idea is to square both sides. So you take x minus 2 and you square it, and you take 3 and you square it, and you get x minus 2 is 9. So x is equal to 11. Now for the check. Remember, all these you must check. So the square root of 11 minus 2 is supposed to be 3. Well, the square root of 9 is 3. So that checks the solution. X is 11. Okay, pretty easy. Number 11. Number 11 says solve square root of 4r plus 3 plus 1 is 0. Now the rule, again, isolate the radical. So we'll get 4r plus 3 now is equal to negative 1, and we can stop here. Stop, no solution. Once we isolate the radical, we get this radical by itself with nothing in front of it, there's nothing there, and there's nothing tacked on the back, and you see a negative. Square roots can never be negative. There is no solution to this problem. You need to go no further than that. Okay, number 17. Number 17. We've got two square roots. That's sort of interesting. Each one is isolated, which is nice. Square root of 9x minus 4. And that's supposed to be the square root of 8x plus 1. 8x plus 1. So we'll square both sides. We get 9x minus 4 is the same as 8x plus 1. Solving for x, take 8x from both sides, add 4 to both sides. We get x is 5. Now for the check. Remember, you have to check. So square root of 9 times 5 minus 4 is supposed to be, question mark, the square root of 8 times 5 plus 1. Well, this is the square root of 45. Take away 4, which is the square root of 49. And that's supposed to be equal to the square root of 40 plus 1. And square root of 41. Oh, that's not right. Where did I go wrong? No, I can't subtract. I added. Square root of 45 minus 4 is the square root of 41. So yes, the square root of 41 does equal the square root of 41. So the answer is 5. Okay, that is the solution. Okie dokie. Number 21. Number 21, we have 3 times the square root of x minus 1. We're going to have to isolate something somewhere. And this is 2 times the square root of 2x plus 2. And the task is solve for x. Well, if we try to isolate the radical, we would introduce fractions. And there's nothing necessarily wrong with that. Notice the square root of x minus 1 is 2/3 times the square root of 2x plus 2. And we can certainly go from there. I think the author's bent on this is to leave the coefficient there and just square. When you do square the coefficient along with the radical. So we're going to square both sides. This gives us 9 times x minus 1 and 4 times 2x plus 2. So when you square the radical, that just gives you this. But you also have to square the 3, and that gives you the 9. Okay, same thing on the other side. Squaring the radical just gives you that, but you do have to square the 2, and that gives you the 4. Okay, so this doesn't look too bad. It looks linear now. We have 9x less 9 is 8x plus 8. So subtracting 8x's, we get x is 17. Let's go ahead and check. We've got to go all the way back to the original. So 3 times the square root of 17 minus 1 is supposed to be 2 times the square root. Let's see, 2 times 17 is 34 plus 2. So this is 3 times the square root of 16 is supposed to be 2 times the square root of 36. 3 times 4, 2 times 6. Yep, 12 is equal to 12. That does check. So there's your solution. X is 17. That was problem number 21. Okay, problem number 25. Number 25. We've got x is equal to the radical of x squared plus 3x plus 9. We square both sides. This gives us x squared. This gives us x squared plus 3x plus 9. We can subtract off the x squares. We'll get 3x plus 9. So minus 9 is 3x, and x is minus 3. Okay, here's the check. All the way back to the beginning, minus 3 equals, wow. Right off the bat, I know this is not going to work. Square roots are never negative. But if I try putting this in here, you'll see that this does not work. This says negative 3 is the square root of 9. Negative 3 equals the square root of 9, and that's just not true. As soon as we got to square root being a negative at this stage right here, square root equals a negative, we know that's no solution. So no solution for this particular equation there. Okay? Okie dokie. Let's look at number 29. That's the next one. Number 29, and we've got radical k squared plus 2k, k squared plus 2k plus 9 is equal to k plus 3. Okay? So we're going to square both sides. Squaring the left side, we simply get k squared plus 2k plus 9. Squaring the right side, be careful, you have to square the entire side, so that's a binomial. K squared plus 2k plus 9 is k squared plus 6k plus 9. Well, subtracting off the k squares, they're out of there. Subtracting off the 9s, they're out of there. We get 2k is the same as 6k. Dividing through, let's see, why don't we just go ahead and subtract the 2k. So 0 is 4k. Notice that in order to be 0, one of these has to be 0. That's certainly not 0, so that has to be 0. K is 0. Let's go back to the original, check. So everywhere there's a k, I'm putting a 0. So I have 0 squared plus 2 times 0 plus 9. And that's supposed to be equal to 0 plus 3. Well, sure enough, square root of 9 does equal 3. Okay? So that's a good check, which means the solution to the equation is 0. Okay. Let's go to 33, the last one in this set. Number 33, square root of r squared plus 9r plus 15. All that's under the radical. And then we have minus r minus 4 equals 0. The first thing we're going to do is to isolate the radical. R squared plus 9r plus 15. And move the r and 4 to the other side. Square both sides. R squared plus 9r plus 15. Now again, just be careful. You have to square the binomial r squared plus 4. So we have r squared plus 9r plus 15 is equal to r squared plus 8r plus 16. The r squares go out and subtract 8r from both sides. Subtract 15 from both sides, we get r is 1. Now for the check. So back to the very original, we have the square root of 1 plus 9 plus 15. Take away 1, take away 4 is supposed to be 0. This is the square root of 25. Take away 1, take away 4 is 0. 5 less 1 less 4 equals 0. 0 equals 0. That's good. Checks. I guess I should have put a question mark here. Don't know whether it's equal until you actually check it, but it does check out. So the answer is r is equal to 1. Okay, The next batch looks like they involve some more complicated equations. It says see example 5 and 6, but I'm just going to jump right into the problem set here. 39, we've got a cube root. Okay, so we're not going to be squaring both sides. We're going to be cubing both sides. We have x squared plus 5x plus 1. And let me go ahead and move that over here so I get a little bit more room. Equals the cube root of x squared plus 4x. And the task is, again, solve for x. So we'll cube both sides. X squared plus 5x plus 1 equals x squared plus 4x. We'll subtract off the x squares and move the 4x across, so we get x plus 1 is 0, so x is negative 1. Let's go back and do the check. We have the cube root of, let's see, negative 1 squared is 1. 5 times negative 1 is minus 5, and plus 1. That's the left side. And on the right side, we're putting x is negative 1 in there. So negative 1 squared is 1, and 4 times negative 1 is minus 4. Now remember, these are cube roots. So cube roots are certainly allowed to have negative radicals. So this is negative 3 here, and this is the cube root of negative 3. So sure enough, they do check. Cube root of negative 3 is the cube root of negative 3. The answer is x is negative 1. Okay. Number 45. We have the cube root of x minus 8. And then plus 2 equals 0. So we isolate the radical. Cube root of x minus 8 is equal to negative 2. Not a problem. If this were a square root problem, I would stop and say no solution. This is a cube root problem, so cube roots can be negative. We cube both sides. We get x minus 8 over here, and negative 2 cubed here is negative 8. X minus 8 is negative 8, so x is 0. And the check, we put it back into the original. Cube root of negative 8 plus 2 is 0. Let's see whether it is. Negative 2 plus 2 equals 0. Sure enough. That's right. So our solution is x is 0. Okay. Next one. Now this one looks confusing because we have, this is problem number 49. There are two square roots. Number 49. So square root of k plus 2. But to that, we're subtracting the square root of k minus 3, and that's supposed to be 1. Okay? We have to isolate the radical. I'll isolate this first one, and I'll move the other radical to the other side, make it positive. K minus 3, just add them to both sides, and square the left. So squaring the left is easy. That's k plus 2. But on the right, we have to square this binomial, k minus 3 plus 1. We've got to square both terms. So that looks like it's going to be some work. K plus 2. Now, I could do this in my head. I'll write it out long ways just to sort of show the steps. K minus 3 plus 1 times square root of k minus 3 plus 1. We are going to have to FOIL here. Right? So left side, k plus 2. Right side, we have k plus 3. That's the first multiplication right here. And then we have plus the square root of k minus 3. And then plus another square root of k minus 3. And then lastly, 1. Okay? So cleaning up like terms, we have k plus 2. I have a k plus 4, right? 3 plus 1. And then I have 2 of these square roots of k minus 3. Still have a square root. I can go ahead and subtract out the k's. I can move this 4 across, so I have negative 2 is 2 square roots of k minus 3, divide through by 2. So negative 1 is the square root of k minus 3, and then I can stop. No solution. Remember, square roots cannot be negative, and right now I have the square root of k minus 3 equal to a -1, not possible. Okay, so no need to check. Number 53. Number 53, we have the square root of 3p plus 4. And to that, we're subtracting, not adding. We're subtracting the square root of 2p minus 4. And that difference is supposed to be 2. So once again, I'll isolate the radical 3p plus 4. I'll move the other radical to the other side, make it positive, 2p minus 4 plus 2. And I'll square both sides, 3p plus 4. This one I'll do in my head. If you don't like the, work it out, FOIL it out. But squaring the radical gives me 2p minus 4. Multiplying the two together and doubling it, that gives me 4 of those radicals, 2p minus 4, and then squaring the 2 gives me 4. Okay, so moving, collecting, and all that. Let's see, the 4's go away. I move the 3p over, or the 2p over, so that gives me p plus 4 is equal to 4 times the square root of 2p minus 4. I can divide by 4, but that will introduce a fraction. So I'll go ahead and square this as it stands to get rid of the radical. I just have to remember to square the 4, which gives me 16. And squaring the 2p minus 4 gives me 2p minus 4. Okay? So let's see. I've got p plus 4 is 32p minus 64. So subtracting p, I get 31p is equal to minus 30. Oh boy, that looks like a messy problem. So right now it looks like p is supposed to be minus 30 over 31. I'm going to go back and just check the back of the book. Usually the author doesn't make this quite as nasty. So let me just see if this is where he's headed. Let me pause things. Okay, back again. Looking at the back of the book, the answer is supposed to be 4 and 20. And obviously I'm nowhere near that at that stage. So let's see where I may have gone wrong. First of all, I'll go back and make sure I copied the problem down right. 3p plus 4 minus 2p minus 4 equals 2. So that's correct. Okay, so I moved this radical to the other side. Okay, so that's good. No problem there. Squaring both sides, squaring the 3p plus 4 does result in that. And squaring this, when I square 2p minus 4, I do get 2p minus 4. When I multiply the 2 together and double it, so 2 times a radical is 2 radicals, doubled is 4 radicals, and then 4. Okay, so far so good. So let's see, what did I do next? I tried to combine like terms. Let's see, so this, use a different color here. This negative 4 and this positive 4 go out. And then I subtracted 2p from both sides. So that gave me 1p. I still had a 4 here. Was there anything left on the right? I had 4 times the radical. So that looks good so far. Okay, then I'm squaring. At some point, I had to square both sides. And this is where I made my mistake. So I squared that, and I squared that, but I did not square this. Okay, so I'm good up to that stage. And now let's just go ahead and square the left side. P squared plus 8p plus 16 is equal to 32p minus 64. Okay, so this looks a lot more reasonable. And we're going to, let's see, move all the terms to one side. So 32 less 8 is 24, so minus 24p, and move the 64 over. So what's that? Plus 80 equals 0. Okay, since I already know the answer, I know this is going to factor very nicely. P minus 4 times P minus 20 is 0. And again, you can just double check the factoring. That's certainly the way it works out. So P is equal to 4 or P is equal to 20. Now, this was a long problem, but we do have to go back and check. So we've got to go back to the original. And let me go ahead and check the number 4 first. So this is the check for x is equal to 4. So we're going to be putting 4 into P. Well, let's see. 3 times 4 is 12, and 12 plus 4 is 16. And then we're putting 4 into here. So 2 times 4 is 8. 8 take away 4 is 4. And that's supposed to be equal to 2. So let's see, this is 4 minus 2 does equal 2. Yep, it does. So that's a good solution. Okay. The next check, we need to check to see whether it works with x is 20. X is 20. So again, I'm going back to the original equation. And I have this, see, 3 times 20, I'm putting 20 right here. 3 times 20 is 60 plus 4 is 64. And then I'm putting 20 in here. So 2 times 20 is 40. 40 take away 4 is 36. And that's supposed to be 2. The square root of 64 is 8. Square root of 36 is 6. And 8 minus 6 does equal 2. Yes, that does check. So this problem does have 2 solutions. X is 4. X is 20. Okay. Let's see. The last one in this problem set, or last 2 in this problem set, number 59 and number 60. Let's see. The directions say write it as a radical and then solve using the procedures. Okay. So I'm just going to go, this is number 59. I'm going to straighten write it as a radical. So we have the square root of 2x minus 9. That's the 1/2 power. On the right side, we have 2 plus the radical of x minus 8. Again, this radical's isolated, so I'll go ahead and square that immediately. 2x minus 9. And on the right side, I'm going to have to square the binomial. 2 plus the radical x minus 8. Okay, so 2x minus 9, squaring a binomial, square the first, multiply the 2 together and double it, x minus 8, and then square the last, which is x minus 8. Okay, so let's clean up and combine terms if we can. Let's see, I'll take this x and move it across. That gives me 1x. 4 minus 8 is negative 4. Add that to both sides, so that's minus 5. And that's 4 square roots of x minus 8. Okay, square both sides again. Make sure I'll put parentheses here to make sure I square. I have x squared minus 10x plus 25. And squaring the 4 is 16, and squaring the x minus 8 radical is x minus 8 without the radical. Okay, so I have x squared minus 10x plus 25 is 16x. And let's see, 8 times 8 is 64 times 2 is 64 times 2 is 128. Okay, so minus 128. Okay, so moving things around again, we get x squared minus 26x and minus 103, if I did my subtraction right. Okay, equals 0. Again, this looks messy. I don't see an easy factoring for 103.13. Let's see. Let me pause this here. Pause. Okay, so I checked in the back of the book again. Good old teacher's getting tired here. The solutions in the back are 9 and 17, and obviously I'm not headed there. So I have to go back and try to figure out where I went astray. And again, I'll just go through each step. I square that, I get that, that's fine. I square this, and I've written that here. Square the 2, that gives me 4. Multiply the 2 together, that's right. X minus 8, and then when I square the radical, I get x minus 8. So far, so good. Okay, so now I'm trying to move things around. Looking on the right side, I have a 4 minus 8. That's a negative 4. Add that to both sides. So I have negative 9 plus 4 is negative 5. That's right. And now I see my mistake. We're supposed to have 2x there. Okay, so I just miscopied. Silly, silly, silly errors. Okay, so everything from here, well, let's see. The right side is fine. It's just this left side is wrong. So let's take it from there. I have to square that. Okay, so 4x squared, multiply the 2 together and double, minus 20x plus 25 is equal to, okay, 4x squared minus 20x plus 25 is equal to 16x minus 128. So 4x squared, we're going to subtract 16x from both sides, so that's minus 36x. And then we're going to add that to both sides. So let's see, I have 25, and I'm adding 128, to 25, so that's negative 103 equals 0. Okay. Now, how are we going to factor that? Okay, so that looks, and then again, knowing the answers are 9 and 17, we can sort of play with this a little bit. Let's see, if I take 4 times 103, multiply those together, right? So that's negative 412, because this is a negative 103. And then I got to break up the negative 412. Well, let's see, to give me a negative 36. Wow, this looks messy. Deep in the problem set, I'm going to grab my calculator. Let me pause this again and grab my calculator. Okay, I want to finish this one pretty expediently. If I multiply 412, see, I have 412. So I've got my calculator here. I can do negative 2 and 106. I can do negative 4 and 53. I'm trying to get to the 36. 53 is, let's see, 53. I want to get negative 36. So we're getting close there. I'm going to use the quadratic formula and see where that goes. Okay, back again. I did a little investigation on my calculator, and I am all hosed up here. I'm going to have to start this guy over from the beginning. I see another mistake I made. And again, maybe old Mr. Bosque is just getting tired here. Let's take this problem, start from the beginning, and we're just going to go through each step nice and easily. Try not to do a lot of things in my head, because obviously my head's not working very well this afternoon. Okay. So, I mean, just as a heads up, I mean, if I'm hosing this up, this is certainly not a test question, although I'm spending so much time on it, it might as well be a bonus question. Let's square both sides. 2x minus 9. Square this side. I have 4 plus 4 times the square root of x minus 8 plus x minus 8. Oh, so 2x minus 9 is equal to negative 4 plus x. There was an x there I didn't see. 4 times x minus 8. Move everything to the same side. Subtract the x and I get x. Add the 4 and I get minus 5 is equal to 4 times the square root of x minus 8. Okay, so this looks like it's going to be way easier than what we had originally done. Now let's go and square both sides again. This gives me x squared minus 10x plus 25, and this gives me 16 times x minus 8. So x squared minus 10x plus 25, 16x minus, what do we say, 64 times 2 is 128. Okay, so we're going to move that across. We get x squared minus 26x and minus 103 equals 0. Okay, 103. So the answers are supposed to be 9 and 17. And if we just check, 9 by 17 is not 103. That should be 1. Let's see, 9 by 17. 3 and 6. That should be 153. And that should be positive. Because I'm adding. I'll just carry the same mistake over. Let's just add 128 to both sides. So sure enough, that's 153. So that factors as x minus 9, x minus 17 is 0. X is 9 and 17. When we check, we put the 9 in. 2 times 9 is 18, less 9 is square root of 9. And we put 9 over there, that's 1. So that's 2 plus 1, that checks. We put the 17 in. 2 times 17 is 34. Take away 9 is 25. And 17 minus 9 is the square root of 3. So 5 is 2 square root of 9, which is 3. Yeah. Okay, so I'm just going to stop. I'm not even going to do the last one. You can do it. It'll be worth 100 points on the test. I don't know. So sorry for the dragging through. Maybe I should turn the music off. Okay, 33 minutes in.